welcome back to another YouTube video by SmartPath Tutoring on GCSE Physics. This one is on resistance and IV characteristics. Ohmic conductors have a constant resistance. For some components, as the current through them is changed, the resistance of the component changes as well. The resistance of ohmic conductors, for example a wire or a resistor, doesn't change with the current. At a constant temperature, the current flowing through an ohmic conductor is directly proportional to the potential difference across it. So R is constant to V equals IR. The resistance of some resistors and components does change. For example, a diode or a filament lamp. Ohmic conductors have a constant resistance. When an electrical charge flows through a filament lamp, it transfers some energy to the thermal energy store of the filament, page 11, which is designed to heat up. Resistance increases with temperature, so as the current increases, the filament lamp heats up more and the resistance increases. For diodes, the resistance depends on the direction of the current. They will happily let current flow in one direction, but have very high resistance of it if it's reversed. Three very important IV characteristics. The term IV characteristic refers to a graph which has shown how the current, I, flowing through a component changes as the potential difference, V, across it is increased. Linear components have an IV characteristic that's a straight line, for example a fixed resistor. Non-linear components have a curved IV characteristic, for example a filament lamp or a diode. Three very important IV characteristics. You can do this experiment to find a component's IV characteristic. Set up the test circuit shown on the right. Begin to vary the variable resistor. This alters the current flowing through the circuit and the potential difference across the component. Take several pairs of readings from the ammeter and voltmeter to see how the potential difference across the component varies as the current changes. Repeat each reading twice more to get an average potential difference at each current. Swap over the wires connected to the battery so the direction of the current is reversed. Plot a graph of current against voltage for the component. The IV characteristics you get for an ohmic conductor, filament lamp and diode should look like this. Ohmic conductor, for example, resistor at a constant temperature. The current through an ohmic conductor at constant temperature is directly proportional to potential difference, so you get a straight line, as you can see on the graph. Filament lamp. As the current increases, the temperature of the filament increases, so the resistance increases. This means less current can flow per unit potential difference, so the graph gets shallower, hence the curve. For a filament lamp, the current will only flow through a diode in one direction. As shown, the diode has a very high resistance in the reverse direction. Since V equals IR, you can calculate the resistance at any point on the IV characteristic by calculating R equals V over I. That's the end of the video. Hope you enjoyed. Don't forget to like and subscribe.